Hello, so today is Thursday the 14th of September 2023 and the title is 2025 Problems. That means the year 2025. It doesn't mean we're going to do over 2,000 problems. In fact, we might only do 2 problems. So the basic idea of this is this: a community solving shared problems is important. It's important in open source and more widely. It's, if you like, the basis of voluntary organizations. And we can think of open source as a form of voluntary organization. So what I want to do is gather problems that might be solved in the next 3 to 5 months. So not problems that will be solved this week or the week afterwards, and not problems that will be solved sometime in the middle of the century, but by 2025, which, put another way, the end of 2025 is the end of the first quarter of the 21st century. And so one of the things we'd like to be able to say at the end of 25 is, well, we've got some sort of vision of the last 25 years or the last 5 years, and some sort of vision for the next 25 years or the next 5 years. For the pedants, Wikipedia and Library of Congress tell us that the 21st century started on the 1st of January 2001, which means that the end of 2025 is, in fact, according to these authorities, the end of the first quarter. And I've said there are extra points for problems from the last century that can be solved by 2025. And I'm interested in all problems related to text, math, documents, command line interfaces, and in particular, accessibility. Now, there's only 2 of us here today, me and Nelson Beebe. And I think we've all got one problem or range of problems that we'd like to talk about a bit. And we've still got plenty of time this year to gather more 2025 problems. And I hope that by the middle of 24, in other words, the middle of next year, we'll have at least some problems and some interest in them and some progress towards solving them. So my problem goes back to the last century. It's one of my first articles in Tugboat. The article's title is Editable DVI Files, or What You See is What You Get Tech. And I'll introduce that in a moment. I've had a conversation with Nelson before this meeting, and he has some interest in resolving a number of long-standing BibTeX problems. BibTeX has, for I think about a quarter of a century, been stuck at 0.9. We know it's got problems, but they haven't been fixed. And I don't know if the reasons for that, but I'd like to have a discussion with Nelson to make that a bit clearer and see if we can't find some things that might be worth doing in the next 15 months. So let me tell you what editable DVI files are and how it relates to WYSIWYG Tech. So another way of looking at it is round tripping. So round tripping means you perform a transformation, but your input can be recovered from your output. So you have a transformation that does something, and it has an input and an output. Now, if you're adding numbers, you want to compress 3,000 numbers into one number, or if you're averaging numbers, you're the whole purpose is to compress things. But in this case, we want to keep the information we've already got and add the rendering information. So that's why I call it value-added typesetting. And I actually ran a web service for a while that did this for formulas. You type in a little formula and you'll get back a bitmap image that had the formula typeset. And the system supported round tripping because the information you put in, the formula you put in with your curly braces and backslashes and everything, so that input piece of LaTeX or whatever, was actually placed into the output bitmap as a sort of comment, which could then be retrieved. So if you ever wanted to edit the formula, you didn't have to find the source separately. It, so to speak, carried the source along with itself.
Excellent.
Thank you. So an editable DVI file is similar, and except it has more granularity. So you'd like every word to have it, so to speak, its input. And the testing of the system is fairly simple. You have an input file in a normalized form. So that's a collection of input text commands. And then you have your output file. The DVI stands for device independent. It's what there was before there was PostScript and PDF. So it's an abstract page definition language rather than a concrete page definition language. And there are DVI to PDF processors. And the ZTeX system, for example, internally has its own variant of DVI that's bidirectional, and it creates an intermediate internal DVI file or equivalent, and then it turns that into PDF. And even modern systems such as LuaTeX, I believe, have an internal tech or tech-like box, which is then turned into PDF. There's no reason why that box shouldn't be shipped out, not as DVI or PDF, but as it actually is inside tech for reuse. And Martin Ruckert's hint system does something rather like that. So there's precedent for that sort of thing. But when I wrote my paper in 1995 or so, and it was published in Tugboat, DVI was the only output format that the tech world used. Anything else was processed. So Nelson wrote a lot of printer drivers, particularly for dot matrix printers, I believe, for DVI files, and Tom Rikiki produced the highly esteemed DVI PS that created PostScript from DVI. So all of those things existed, and the advantage of using DVI is that it's a simple format and that it allows us to focus on the basics and make progress quickly on the things that we need to deal with. So it's good for toy projects, and it's maybe good for serious projects as well. So the basic purpose of a editable DVI file is that the user can interact with it as if it were the original source document, if that's what they wish to do. So if the DVI file contains the original source document, they can edit the original source document and ask for the thing to be reprocessed. And the granularity should be such that you could click on part of the document and the system should be able to do an inverse search, so to speak, and say, oh, this is where this piece of text came from. And one would like, if the piece of text was generated text, that it could also say where it came from. So if it was a generated text theorem, it should sort of tell you why that word theorem is there and how you could change it to something else if you want to. Now, here's something that's quite interesting in this, which is that if you have an editable DVI file, you can also screen read it. And that's what the people who don't care about the typography because they're blind want. They want to be able to read the file or have the screen reader read the file. They don't want the visual representation. So if you, and it's not difficult, I don't think, if you had a DVI previewer that worked inside your web browser, you could then use the editable DVI file as something that a blind person can use with a screen reader, and it would allow you to short circuit all the problems with PDF and all the problems with Adobe standards and everything else like that, just to get something that works quickly that can easily be tested. So something I recall reading is human-powered flight, which is hard work for the cyclist. Now, the people that were successful in it, they didn't try to build a perfect plane. They tried to build a plane that would crash often and could be reassembled in a different way easily. So they wanted something for which the development loop was rapid. And I see the process of editable DVI files as having that sort of rapid aspect to it, because essentially you're not bound by existing standards. And indeed, the existing standards should be based upon human experience, and particularly the experience of disabled people. And so there has to be an iterative thing, has to be iterative. Stephen Krug, in his wonderful book on usability, it's called Don't Make Me Think, said, oh, well, when you do usability testing, just bring in one user, two user, test it for half an hour or an hour, and you'll find enough faults to keep you busy to solve it. And when you've solved those problems, other problems will emerge that weren't visible before. So don't try and just have a waterfall. Here we are now going to do the usability testing, and when we say we finished it, well, it's goodbye to everything. We want a much more sort of a workshop and agile approach to all of this. So that's how it goes there. I see a number of benefits to all of this, and here's one that's quite interesting, which is that the main function of tech when it's typesetting a paragraph is to break the paragraph into lines. So you have a long line of text in the input file, or at least morally, if not literally, and you break it up into lengths according to how it typesets and according to the paragraph algorithm. So if you take that output and you've got round-trip typesetting, you can view the process as being this, that you've got this long line of text, and every so often you're putting in a line breaking hyphen. Every so often in the text, you're putting in a line breaking hyphen. And if there are some ligatures involved, then what's happened is a bit more complicated, but it can be described. And so one ought to be able to produce from this a version of the text where the input lines match up exactly with the output lines. Now you might think, what's the point of that? Well, it allows you to number the lines. It allows, and you could do the same for paragraphs and same for pages. And that solves something very important, which is sighted people use page numbers and location on the page and line number on the page as a way of referring to where things are. And you can't stop them doing that, and it's extremely convenient, and they'd rightly complain if that was taken away from them. So you have to provide it to the people who are blind, so that the blind person can say, you'll find this on page 37, line 14. And the sighted person will be able to find that exactly as it should be, and perhaps not even know that the person gave the reference is blind. So as long as you're using line numbers and pages as a way of referencing, it has to be made available to the blind people. So the key point of value-added typesetting, which is that typesetting consists of deciding where to put the line breaks in and deciding where to put the page breaks in. That's the main purpose of typesetting. The algorithms are to make good decisions as to where to break the paragraph into lines and where to break the lines into pages. And it also has to do clever things with mathematics. But those things are, in a certain sense, annotations or insertions into the XML, if the XML is the underlying document format. I'll say a word about XML, which is that tech is a typesetting program, and its whole purpose is putting marks onto a piece of paper or filling in dots in a bitmap array, and thereby either putting marks on a piece of paper or putting something up on screen. But it's a visual thing. It's all related to seeing things, perceiving things with the eyes. Now that so many things are done with computers, the visual side is not as dominant as it is before. I have no doubt that the number of computers, if you take an average mathematical paper, the number of computers that read it is probably approximately equal to the number of human beings that read it. Because the computers have to read it for indexing, for searching. Every time I search for Fibonacci in a paper, a computer is reading that paper. So the number of times a computer reads the paper and the number of times I read the paper might be approximately the same. And the information storage systems, searching and indexing are all questions of computers reading things. So I'm going to stop at that point, except to say this. I think that it is possible by the end of 2025 to produce a proof of concept system whereby one has round-trip typesetting. In other words, one has some not completely trivial, or if you like, moderately complicated documents that go in a typeset, and from the typeset output, which I'm calling DVI, you can then regain the input file together with the value added by the typesetting process in terms of location on page and location of page breaks and that sort of thing. By the way, if you do that sort of thing, then because you know exactly where the page breaks occur, the long-standing problem of how do I change the color of the foreground font disappears. You see, what happens is that the page break occurs in the middle of a paragraph. And so the start using red as the front color and stop using red as the front color are not on the same page. And you've got a left parenthesis, and then you've got a right square bracket, and then you've got a left square bracket, that's the page break, and then you've got a left parenthesis, right parenthesis. In other words, the parentheses and brackets are not properly nested, and they can't be. And if the system on the second time round knows exactly where the page break is going, line break and the page break is going to occur, it can do the adjustments required at the break. So at the break, you need to say, okay, well, we're currently in red text. We have to stop that red text, otherwise the system will complain. So we'll stop that red text. And we also know that this continues on to such and such on the next page. And before we do that, we must resume the red text that we previously stopped. So the page breaking does some, what's the word, bookkeeping. And that bookkeeping becomes a much, much easier business if you've got round-trip typesetting. Because you can then say, this is something happening at this particular location. And it's almost as if the typesetting system, having seen everything once, is psychic and knows exactly what's going to happen at the next time. So when the second time around, when the end of the page comes, it knows exactly what to do and when to do it and what should be done. It's almost as if it's psychic. It's almost as if it's been that way before. So I'll stop because Nelson has something to say.
I have the tail end of a cough, and so I've taken a cough drop and I'm drinking water to keep my throat lubricated. There are some, this is a lovely ointment, but there's some flaws in it.
I'd love to hear flaws.
You haven't said anything about comments, and comments and input documents are important. For example, in my big fat book on mathematical function computation, in the manuscript of that book, under complicated math displays, there's generally a comment block. where that equation is produced in Maple or Mathematica or some other algebra system, document that indeed this is what the mathematics ought to look like. That's extremely important. In the BibTeX files, it became clear very, very early on that just a list of references was doubtful utility, shall we say. One has to have a comment preamble in bibliography that's, for example, a subject bibliography, to explain why is this bibliography collected, what does it cover, how many entries are there per year, and so on. And so those comments have to be a first-class object. And so when I wrote the grammar for BibTeX that was published in Tugboat in the 1990s, comments were a first-class object, and they're treated as verbatim text, so they're absolutely preserved. Similarly, line breaks indicated by double backslashes are preserved in string values. And the reason for that is if you have a table of contents, as say part of a book entry, which is quite important because it tells what the contents of the book are, which is much more informative than two words like the tech book. We have a two-word title for the most famous book in this field of typesetting. It's important to be able to keep that table of contents readable, and if it were treated as flowed text, it would be completely useless. So comments have to be a first-class object. They have to be preserved in the output. And currently, in no document production system, whether it's word processors or it's TROF, NROF, or it's TeX, or it's PDF Tech, or LuaTeX, or ZTeX, none of these preserve comments. They're gone. They're discarded as TeX is parsing the input, or as the document formatter is parsing it. So that's a flaw. Second flaw is that although TROF does in fact mark word endings, TeX and many word processors do not. You have to try to recover words from spacing between the glyphs on the page, and this is fraught with peril. And it's particularly a problem for screen readers where recovery of those words in a form that can be pronounced is quite important. Thirdly, there's this matter of the introduced hyphen when you hyphenated a word because it was too long to fit on the current line. I thought this might have a simple solution several years ago, and I looked into it and discovered the solution isn't simple. And the reason it's not simple is TeX has this notion of a thing called \hyphen char. And this is all well and good. Unfortunately, hyphen char is not a macro. It's a position in the font, which is almost invariably the same as the hyphen or the minus sign in the font. So you can't tell, you can't redefine it to be a macro that puts something special into the DBI file that says, oh, this hyphen you see here at the end of the line can be taken out. And that's a design flaw in TeX. We simply have to live with it. So these things add up to difficulties for reconstructing text. So
can I respond?
Yeah, so I was just going to make one comment. So my argument is that really one ought to be doing what archive.org is doing, keep the input file and keep the output file. Most users will read the output file, but should they want to edit the document, update it or whatever, the input file should be available. And it wouldn't matter to me if in a typeset document, it was always paired with an input document or whether it was somehow magically bundled in with the typeset output. The important thing is that the exact input ought to be available, and regrettably it's not. And of course, when you have TeX macros in play, which is extremely common, especially in LaTeX, where you have lots and lots of packages, what the user has written could be quite far from what is actually put into the DBI file or the PDF file, because a macro or multiple macros got expanded and did magic things. So that's why I think preservation of both input and output, as archive.org has done, is exactly the right thing to do. So anyway, you can now respond.
I prefer to think of what you said not as flaws, but as forces. So particularly my mathematical research, when I do a calculation that has an unexpected and unwelcome outcome, I become aware of a force that I was previously unaware of. And accident investigations are often discovering, well, sometimes they discover human stupidity, which is quite large, but sometimes they discover forces that were people were unaware of, and there are all sorts of forces. So you've given me a number of forces that I don't imagine I can satisfactorily deal with by the end of 2025, but having forward knowledge of those forces will be very helpful.
Interject on the issue of the introduced hyphen. Martin Ruckert dealt with this in his hint tech, in the talks I've heard by him, by putting into the hint file all of the hyphenation variants that tech considered before it introduced a hyphen. And that way, when he's reflowing the text, he doesn't have to deal with the hyphenation problem. Tech has already done that in a very good way, but he has all of the possible hyphenations available, and he can choose the optimal one for the display size that the reader has currently chosen. So there's hope that the hyphen problem does have a solution, and Martin has found out how to deal with it. But these other problems aren't there.
I've written down Martin Ruckert's provides prior art. That's
important.
It's really important. It's really important. It's really important to do the right thing regarding that statement.
Yeah, Hint is really a remarkable project because he set out to do something that tech never intended to be done, but he recognized that with the trend towards people viewing documents on all different sizes of displays, not just a fixed computer screen or a fixed printed page, you have to be able to reflow text.
Yeah, if I can get this system working with Hint or something, or some variant of Hint, then both systems will benefit greatly. So there's a synergy there, and that's really, I think, one of the key things about projects that succeed is the amount of synergy that they involve. I'm not thinking of using LaTeX as the macro package because of all the difficulties that you mentioned. Because of all the word endings is one of them. I view the problem of determining where a word begins and where a word ends as being different from the problem of typesetting. And the input file
knows about it early on, but as soon as it starts shuffling word boxes around, it still knows where the word boundaries are, but it neglects to put it into the DBI file.
Oh, wait. If we just focus on word endings, if the system typesets a sequence of words, then every word should have a begin word command at the beginning and an end word command at the end, and probably
that
every word should
hyphenation problem too.
Yeah, but just for the word, and the word beginning should probably have an ID. Every word should have an ID, so that, and if the word is hyphenated only at one location, you can match up the head and the tail, just because both pieces have got the ID.
If you had a unique identifier, that also provides a lovely pointer to the exact point of text you want to refer to.
Yeah, yeah. So a lot of the things that LaTeX lets the system do should so when I say it's WYSIWYG, there's what the author reads, what the author writes, and that's one sort of input. And I see that as going through a non-typesetting transformation, which adds value, which is round tripping, that produces a typesetting file. And then the typesetting file should be typeset, and the input typesetting file should be reproduced, should be obtainable from the output. So I want to narrow down very much the typesetting part of the process so that I have a manageable project. And the text processing part of the problem, which includes the matter of what might be called macros and generated text, lies as part of a different system. So a different system feeds material, gets material that is then fed into the typesetting system. So that's word endings and macros. I fully agree with keeping input and output. XML has this nice concept of normalization. So you have an XML document and you have this sort of element content information set, I think it's called, and you can normalize the document in such a way that once the document is normalized, the irrelevant differences have gone and the important differences remain. And that particularly means that the same document always, two different representations of the same document have the same normalization. So implicit in all of this is some concept of normalization. You might have a normalization that includes the comment and a normalization that excludes the comments. So, I'll say something about the first thing, which is metadata comments. Comments also come in the form of metadata. So your web page has got metadata, which doesn't appear in the web page itself when it's displayed, though part of it appears as the title of the window that holds the web page, and also has terms that are important for search engines. And an annotation is also very, very interesting and very important. I had a comment at a meeting I was at where he said students are used to have their workflows for dealing with the documents, and for PDF they use annotations. And until we solve the problem of annotations for HTML, because for PDF the problem of annotation seems to be solved, we've got a problem. We're going to have to keep providing that PDF so that students can keep using their workflow. So even though one wants to keep the source document, if the source document is, so to speak, inside the PDF DVI that you produce, then the annotating process can actually refer to par locations in the source document. So you can actually annotate a specific word or range of words. And that's remarkably useful. And on sites such as GitHub, you can view a file and you can create a URL using hash for page fragments that refers to a particular group of lines in the file. Because this group of lines, and when you visit that file with that particular page fragment, those lines are highlighted. So that sort of thing is the power of annotation. They are different media and we have to respect this. And the source documents that authors write and what I would like to consider the source document that is round tripped are not the same, and we have to respect that. But I'm not trying to solve everything. I'm trying to create the conditions for going forward and then for going forward again. And I'm going to stop because I promised we stop at 7:30 because you've got important business afterwards.
Well, one of the important things, I think, is what you mentioned early on, the notion that when you have an equation, what the reader wants to see is the familiar mathematical display. But if the reader also wants to say, well, gee, I'd like to use that equation in my document, that displayed form is of no use to them. They have to reconstruct the input. And therefore, I think it would be extremely valuable to have any kind of a document formatting system preserve the input for mathematical displays and musical displays as well. Because they're both have the feature that they're two-dimensional and they cannot be reflowed. They have very specific spacing requirements for understanding meaning. So it would be really nice if you could click on an equation and have the LaTeX displayed for you. And I think there's probably work going on for character recognition in mathematics, but I must say, since I deal with an awful lot of mathematics from publisher web pages, it's botched far more often than it's done successfully. And in particular, one thing that publishers, or at least the people who are doing the publication work for them, have not really understood is that mathematics cannot be replaced by a Unicode string because there's a two-dimensional aspect that's been lost. And it's just a very simple example. Unicode has a square root symbol, but in mathematics, square root is an operator that has an argument. And you have to know what that argument is before you put the square root symbol in front of it. So it's completely useless to have a Unicode square root in front of a plus b plus c because you don't know, is it the square root of a or a plus b or the three of them. And so I would like to see mathematics handled much better. And I think the best way is to use the input language that has been for 45 years now, demonstrate it to be pretty adequate for almost all uses in mathematics, including physics and chemistry and so on, to use the input language of tech to display that mathematics. Because the alternatives that people have proposed in the form of MathML and so on are so verbose that they're not usable by a human. They can be used by a computer program, but that's not what we want. We want a simple input stream that for most purposes is unambiguous and easily intelligible by someone who's familiar with mathematical input.
We want something that works for a wide range of readers, some of which are not human.
Right, and especially for people who need reading assistance for a technical document because of visual limitations. If they had the tech input, they can often understand that quite easily. But if the reader says, well, we have this funny thing that I think might be an integral sign, and down below it is the beginning of the integration range, and up above it is the end of the range, and so on, that can get very complicated to understand. Whereas if they knew that it was just \int underscore something, caret something, they'd say, oh, I know what that is. And they'd carry on with no difficulty.
I'm not sure I completely agree with you, but I agree with you sufficiently that we can proceed as if we did agree.
I mean, just as an amusing historical anecdote, some 25 years ago, we had a special year in mathematical biology at the University of Utah. And this involved people coming to visit for 2 to 8 weeks at a time. And at the end of the year, each of them contributed a chapter to a book summarizing the research experience of the year, which was a useful thing to do. One of them, regrettably, had handed off the job of preparation of the manuscript to someone who was completely unfamiliar with tech. But whatever that person got was a mathematical display of some sort. So the way they coded that in the file that they sent to us was they learned that tilde in tech was an unbreakable space. So they put a string of tildes and n, and then below that, a string of one fewer tildes and an x, so that it read x to the n when printed. But of course, it's completely meaningless to the computer. And it basically, we had to redo all of the math in that paper from scratch. So having an understanding of how to do mathematical markup is important. And I see no harm in teaching it even at the high school or even junior high school level, because it isn't that complicated, especially for the kinds of mathematics that one has in schools. The most that they ever need is a subscript and a superscript, and possibly in high school an integral sign, but many never even see that.
I think we should come to an end, really, because I know that
I think we've got some great ideas on the table, and I've tossed back. You've put some great ideas on the table, and I've tossed back some. Well, here are the difficulties for doing this utopian mission. But you have to understand both aspects. What can we reasonably achieve, and what should we ought to be able to achieve in a perfect world?
So next week, perhaps, we'll reverse roles and you'll tell me about BibTeX.
Yeah, we could do that. Sure, that would be fine. I'll try to think more about, maybe make up a list of pain points in BibTeX. There aren't very many, but nevertheless, there are things that really ought to be fixed. Because
that sounds to me like a good choice for a 2025 problem, even if it's not done in 2025. Yeah. It's we should know about these problems.
There are a fair number of bibliographic formats that people have proposed, including ones in XML. The bibrefer system in Unix world, and Papyrus and EndNote and RIS and so on. But having looked at all of them, or a great many of them at least, I see none that can remotely compare with the flexibility of BibTeX. This BibTeX is intended to be readable both by a human as well as a machine, and the machine has been taught that when you see a key value pair that you don't recognize, you quietly ignore it. And that means you can annotate BibTeX entries with extra things that you need to describe things you want about that entry, things that will be helpful in searching, for example. I use that in important papers of making remarks about different parts of the paper. So I have remark 1, remark 2, and so on. And I cite a fragment of text from the paper and comment on it within the string value. And those have been enormously useful in finding things with searching. But of course, you never need that information when you're simply displaying the reference in the reference list.
This is what you call comments and what I call metadata.
Yeah, it is a form of metadata, but it has to be a very flexible one. So, for example, just a few years ago, a group of people in the publishing industry got together and said, we really need a way to have unique handles on authors because there are too many John Smiths in the world. In China in particular, there's only 300 family names compared to Italy, which has about 75,000 of them. And the English world is about 50,000. So they came up with this ORCID, ORCID system, where you get a handle like Nelson Beebe / and a long number. And they made a restriction that you cannot apply for such a handle for dead authors. So we can't get them for Isaac Newton and Albert Einstein, but at least living authors can get them. And ACM a few months ago mandated that the submission of ORCID IDs for all new papers submitted to the society, which I think is a good thing. So once those became available, I started retrofitting them into bibliographies. I updated tugboat.bib this morning with a couple that I happen to have values for. But any system that had a predefined set of keywords would never handle this. And that's the difficulty with all of the other ones, that they don't have any mechanism for extension. And BibTeX, as far as it's concerned, it sees name equals value separated by commas. So it has these name value pairs. And that's all it needs. And it takes the ones it can handle and ignores all the rest. And that's made it wonderfully flexible. And you don't even have to use it for BibTeX entries. We have our equipment inventory in a database that is BibTeX entries. Now, why would we do that? Well, the way the central office maintained this before was a spreadsheet. But when you have a description of computer equipment, the fields are rather long, and it would never fit on one page. And it was completely unmanageable. So I took the data they had in the spreadsheet and turned it into BibTeX values, where you have essentially, instead of a series of columns lined up like this, each column is a row. Each column entry is a row in the BibTeX file. And that can be spanned multiple lines if it needs to, such as a description of a piece of equipment. And that's proved extremely useful to us. We don't have to make tables from this data. We merely have to be able to find when we buy this, what was the purchase order number, and so on. And it's been very flexible and very useful.
In SGML, they allow you to specify that a certain piece of content is characters, but associated with the characters is what they call a data content notation, which tells you how the characters should be processed. So that it might be, this is a LaTeX mathematical formula, and that's a data content notation. And then the SGML parser can use that information to properly process whatever that piece of content is. So it might be that this is an ASCII representation of an image, for example.
Yeah, another example is JSON, the JavaScript. I'm not sure what the ON stands for. It's
object notation.
Object notation. It's a key value idea, but what they do is they store the keys once at the top, followed by objects, each of which have exactly the right number of values in exactly the right order. And this is fine for machine processing, but it's hopeless for a human to maintain, because they can't possibly add an extra field in the middle of an entry without redefining all of the entries of the collection.
I think that's a big area of discussion and awareness, which is notations that are suitable for humans and notations that are suitable for computers. And a substantial part of the usability of programming languages is related to these notations, different sorts of representations of things. This representation works well for the needs of computers, and this representation works well for the needs of humans.
Yeah, and these compact notations like JSON, where the keys are specified once, seems to be desirable from the point of view of storage economization, but I argue that's meaningless for two reasons. One, data compression can take care of that tremendously. I mean, I have log files that decrease by a factor of 1,000 in size because they're so repetitive. Secondly, computers should work for people. People shouldn't work for computers, but people need to understand the data that the computer is processing. And so having a format like BibTeX, where there's a clear indication of the key name and the value of that key, even if it's a little harder for the computer to look up that key and figure out exactly where it should stick it in its internal representations, that's a sacrifice I'm willing to make. I think it's really, really critical to have readable files that you can debug as a human, because when things go wrong in a computer, you can be really up the creek without a paddle, because you have no idea what happened to the data as it processed through a stream of either separate programs or even one large complicated program.
I'd like the computers to run quickly when I'm waiting for the result.
Right, but I argue that the time it takes to do a hash table lookup is going to be in the microsecond range. No human will ever notice it.
Oh no, but if I'm doing a large, well, the standard example is reading and writing to disk. That's often a bottleneck in computing, and what's happening with the increasing power is that things that we were happy to wait 10 seconds for, like processing a page or something, We're no longer happy to wait 10 seconds for. And
the storage problem, access time, I think will ultimately get solved. We've seen progression from magnetic tapes and floppy disks and punch cards to spinning disks to solid state disks, and then more recently to NVMe type non-volatile memory storage. It's much
yeah, I have them. They're good,
and that helps tremendously. Now there's still overhead in the process that one can eliminate, but I can tell you about some recent activity in the FreeBSD world. They were thinking about the problem of having virtual machines running FreeBSD that you would spin up, answer a database request, and spin down.
Oh, I've read this.
And
I read about this on Foreignex. They got the boot time down to 40 milliseconds or something.
Exactly. Whereas a typical boot time, I have hundreds and hundreds of virtual machines, and they typically take 10 to 100 seconds to boot. So getting something down to sub-second range is really remarkable. And they did it by saying, well, look, when I'm doing this virtual memory machine, this virtual machine processing of a customer query, I don't need to check, do I have a disk available? Do I have a video display and audio and keyboard and so on? I need just a minimal number of services to do my job. And so they went through the boot process very carefully and eliminated everything that really wasn't needed for that application. I think that's remarkable progress, and I'd like to see it happen for other operating systems as well, because I think the same idea is certainly applying.
I think that's an example of, as time goes by, there are different forces involved, or the forces that are involved manifest themselves in different ways. So the idea that you would boot up a virtual machine and do its processing and exit in the time of the blink of an eye is a different sort of force than we don't have enough money to run two of these machines, so we'll run one of them virtually.
Right. And for service providers, it's a huge win because they're providing large clusters of machines, each of which should be able to do some work. And if you can eliminate a 30-second or a 1-minute boot time to answer a question that can be answered in milliseconds, you've freed up almost all of your resources.
Yeah, it's a different way of solving the problem of reproducibility and performance. I'm impressed by I think there's a sort of there's a result in databases, and I can't remember the name of it, but it's a mathematical theorem, that's the thing that impresses me, which says there are 3 criteria that are very important, and you can have 2 out of 3, but you can't have all 3. You know, it's like in business. You can have quality, you can have cheapness, and you can have delivery. You know, you can have it tomorrow, and you can have it good, but it will be expensive. Or you can have it cheap, and you can have it good, but it'll be next year. A large part of that is dealing with the forces, and tech was a compromise that was made in certain constraints. And I don't know, it might have been you that told me that Don Kennedy said, well, the reason why I didn't do any memory allocation because I wanted to write a typesetting system. And if I did memory allocation as well, I wouldn't have enough time to write a typesetting system. That's my gloss.
Also, as people have since discovered, there are 2 problems with memory allocation. It's altogether too easy to introduce hard to find bugs. And number 2, in mission critical or time critical applications, memory management may not be acceptable. You can't pause to do a garbage collect when you're trying to launch a missile or something like that.
Yeah.
Just for real-time human response, you don't want delays happening. And those of us who are Emacs users remember in the early days, when memories were quite small, that Emacs was struggling hard to keep its data structures around and garbage collected and so on. And it would simply issue a statement, I'm garbage collecting, I can't answer your request right now. In 10 seconds, 40 seconds later, it would proceed. It doesn't do that anymore because machines have gotten much faster and much bigger. So it's the garbage collection is happening, but we just don't see it.
I heard a different acronym for Emacs, which is that my machine has got 8 megabytes and is constantly swapping. 8 megabytes and constantly swapping.
Yep.
But it's not an issue. It's not an issue now.
No,
I open Emacs, it opens like zip,
And
it's open.
Emacs,
It's open.
Emacs with its programmability has saved years of my life and made it possible to do things that were completely unthinkable with previous generations of editors. And that's been enormously important for me. And I do a lot of different things on computers. I write software in many different languages. I write documents. I do email processing and so on. So I have lots of different tasks, deal with web pages and HTML and XML and so on. And Emacs has been the ideal tool. And what I tell students is, look, you're going to spend the rest of your life dealing with computers. Why not isolate yourself from a particular platform by not using platform-specific tools? Use a tool that runs everywhere. And Emacs has been ported to every operating system. So that's the editor you should spend time to learn.
I think we should stop because, and thank you very much for your 1, 2, 3, 4, 5, I think, 5 holes below the waterline. I hope not, but things to be aware of. And I look forward to trying to have a discussion with you about BibTeX next week.
Okay.
If you're still up for that.
Oh, absolutely. Yeah. I deal with BibTeX every day, so it's always fresh in my mind.
Okay. So until next week, I'll say goodbye.
So long, Jonathan.
Bye.
Have a good week.